computing and mathematics, and the implications in 21st century innovations. As a practical component, you will also be introduced to the basics of computer programming. This will serve as a solid foundation for any programming journey that you choose to take up after this course. Computing is a dynamic, fast-paced world, and it is imperative that you stay up to date with the latest trends. This course explores fundamental principles and concepts in computing used in modern business and society. The aim is to align you to the analytical and mathematical angle of computing, as it is the very foundation of problem solving in everyday life. The little challenges along the way will equip students with a solid base for the highly sought after algorithm development skills in industry. Our mission here is to change lives by providing great education, which is accessible and affordable to everyone all over the world, giving you the flexibility to learn your way. We are globally recognized and align with the standards of education in countries all across the world. Here at Shaw, we offer real engagement, qualifications, and success, giving you the most up-to-date industry developments with subject matter experts like myself, allowing you to master your practical skills and achieve your goals. You will have all received the course outline in your starter packs, so make sure you reference them as you go. We will be keeping an eye on each of those practical skills and demonstrate how you're building them up with each lesson and each module. Remember that this course is a 16-week course, which consists of 4 modules. Module 1 is basic, Module 2 is intermediate, Module 3 is advanced, and Module 4 is considered to be proficient. By the end of this course, you should be able to have a good understanding of core computing principles, including hardware and software. Comprehend the importance of problem definition as the basis of computing. Understand the significance of computing in the way the world is shaped in the 21st century. Read and understand code and the flow of a program. Formulate pseudocode from a stated problem and gather the requirements for solving the problem. And finally, demonstrate a good understanding of the basics in algorithm development using C. If you haven't already, I would recommend that you download our app to attend lessons on the go and manage your class schedule. You can attend your lessons and watch recordings on any device: laptop, desktop, tablet, mobile, you name it. Remember, you can always change your class date and time so it is convenient for you. And should you feel the need, you can restart the course, or you can watch a lesson to reference back to it at any time. Samuel Masuka is your subject matter expert for this course. My name is Nina Smith. I am the one behind the voice you're hearing now, and I will be presenting this course. Samuel graduated with an honors degree in computer science from BUSE. He has vast experience in tutoring, particularly as a lecturer at Kwei Polytechnic College, where he taught various computing courses in the electrical engineering department. Samuel has also been a manpower upskilling trainer at Higher Life Foundation, a division of Zimbabwe's largest telecommunications network, Econet Wireless Limited. Samuel has also worked in software development and system administration. His specialization is in hardware programming, and he has quite a few hobby projects such as an AI-driven security camera. The objectives for today's lessons include understanding how computing came into being. We will look at the things that people were doing that made them want to make computers. Discovering modern-day applications of computing, the way computers are being used, and the exciting ways in which you can be part of this action. We will learn about all the new jobs computing has created, and all the mind-blowing ways in which computers are being used in completely new industries. Morpheus is our resident AI chatbot, and he will assist you with any questions you have during the lesson. If you are attending the live lesson as opposed to a recording, you will also be able to chat to your fellow classmates. If you receive any strange responses, please let us know via support@shawacademy.com. Let's dig into it. Our first objective for today is to fully understand what computer science is. You may be thinking to yourself, what are all these new big words I'm hearing? Don't worry, we're going to go through everything. Computer science is the study of computational systems. Essentially, we study how computers think and programmatically help them to solve problems for us. While that is a very crude definition, it gives us a really good idea of the journey that we have just started. Computer science is at the heart of software and software systems. It starts out at the theoretical side of things, moves into development of the system, and ends at application. That is, the actual deployment of the system. It doesn't really end here, though, as systems are constantly improved and perfected. Think of how your phone or computer has received a number of software updates since you started using it. Computer science is a very big field that consists of a lot of branches, to mention a few. There's artificial intelligence, computer systems and networks, database systems, human-computer interaction, vision and graphics, software engineering, bioinformatics, and theory of computation. This is not even the whole picture. There are a lot of other fields that you'd probably grow old while still trying to explore. This is where people do specialization. For example, you could find that someone studied computer science but only does computer vision, or only develops games, or new programming languages. This is what makes computer science special because there's literally no limit to the directions you can take. You can apply computer science in agriculture, racing, cooking, beauty, leisure, aerospace, art, literally anything. We will pick up a number of new words along the way. These are probably the most important of the lot. Programming refers to the creation of instructions that a computer can understand. Coding is pretty much the same as programming, just a more fun, geeky way of saying it. Language would be the specific method for communication that one employs when coding. And execution is the actual processing of the instructions presented to the computer. You are going to see these words a lot during this journey and probably for the rest of your life as a programmer. Why do we even need computers and all this math? Why can't we lead simple lives without all this buzz? Well, there are several reasons why this is actually good for us. Firstly, it makes repetitive tasks a whole lot easier. Imagine if your grocery store cashier had to add the totals of your groceries by hand. Then do that for every shopper over and over and over and over and over. Me saying that is already boring. Now imagine the cashier having to do that all day, every day for the entire year. They would be tired of their job before you can finish saying, "I've had enough." Computers made all this automatic. Now getting the totals and paying is just a quick swipe on a machine. And presto, done. As we progress with the lesson, you will see the many ways in which automation using computers is taking center stage. Computers are also generally much faster at accomplishing complex tasks. Imagine how fast you can search for a particular topic in a PDF. If that 2,000-page book is printed, it would take you probably 15 minutes or more. Computers are generally accurate as well. Imagine the number of errors our cashier from the previous example will make after crunching numbers all day, and all the people that will come back to complain. Computers not only work fast, but they're incredibly accurate as well. Here, it's worth noting. A computer is only as accurate as the data it is provided with. As the saying goes, garbage in, garbage out. If you feed a computer garbage, you will definitely get shiny, freshly, accurately processed garbage as output. Computers are getting smarter, though, and are now able to reject many common forms of garbage before it even gets processed. In later lessons, we are going to go a bit deeper into how this works and how you, as a programmer, prevent GIGO. Now, for the part that scares away a lot of people, the relationship between mathematics and computing. Don't worry, you have come this far, and I'm sure you can already see how fun and not so hard computer science is. Scientists throughout history have said that nature is mathematical. A lot of things in nature can be described using mathematical expressions. Arguably, the most popular is the Fibonacci sequence. In Module 2, we are going to look at this in detail and see if it really works. To get a good picture of how wildly accurate this claim is, think of the last time you played a computer game, say Need for Speed. Everything in the scenes, the trees, the road, the cars, the voices, the people, everything is a mathematical expression. Mind-blowing, isn't it? As you progress with computer science, you can take up a course such as game development to get a picture of how this works. Other things like where a ball lands when you kick it, the top speed your car can reach, the shape of leaves on a tree, the motion sequence of the flapping wings of a bird as it flies, the path an ant follows as it crawls, can all be expressed mathematically. That's not all. We can go as far as, say, the ratio of your weight to the compressional capacity of your bones, the proportions of your arms and legs, the patterns on your fingerprints, the geometric features on your face that enable your phone to identify you, and so forth. It is amazing how mathematics is in every bit of our lives. Computers help us understand these models, and it is the job of a computer scientist to formulate these models from nature and take advantage of the speed and power that computers offer. Did you know that pilots learn to fly without even leaving the ground? Because computers can accurately model and replicate the scenarios they will experience when they eventually take to the skies. As a result, flying is one of the safest ever forms of transport. Kudos to computer scientists. Still to come in this lesson, the history of computers and the application of computing. To understand how all this came into being, let's take a quick detour into history. Computers existed as far back as 2 millennia ago in the form of abaci, used by Mesopotamians for simple calculations. Our point of interest, though, is a bit recent. Charles Babbage, a British mathematician, inventor, engineer, and philosopher, is considered to be the father of the computer. He built what he called the difference engine. It was a massive automatic mechanical calculator that could do lots of mathematical operations. It mechanized a series of calculations on several variables to solve a complex problem. Like modern computers, the difference engine had storage. It was designed to stamp its output on a soft material. This was bare bones, but the structure of the modern computer was beginning to take shape. The difference engine was a marvel in its time, but it didn't really address the problem that people had. They needed a general purpose computer that you could throw problems at and it would give you the solution. The electronic numerical integrator and computer was the world's first general purpose computer. It was a massive thing, weighing it at a whopping 30 tons. It consisted of 18,000 vacuum tubes. Now, vacuum tubes were the switching bits that were used before transistors were invented. They were made of glass and quite bulky, hence the size and weight of the machine. It used a lot of power, 160 kilowatts, and occupied about 167 square meters. Yes, about the size of an entire bachelor apartment. Around that time, it was exciting because it was programmable, and that makes it interesting for us as well as the fact that it brought about computer science. This also meant that it could be made to do many different things. It was used for weather predictions, cosmic ray studies, random number studies, and wind tunnel design, to mention a few. The ENIAC could do 5,000 additions, 357 multiplications, or 38 divisions in just 1 second. Dr. John von Neumann made changes to the ENIAC to make it easier to program. He is a notable figure in computer science. He is the author of the von Neumann architecture, the base design of all modern computers. We will take a closer look at this in Module 2. Programming the ENIAC wasn't nearly as easy as it is nowadays. It involved weeks of downtime and carefully switching cables around in plug boards. With the invention of the transistor came better and smaller computers. A transistor is a device used to amplify or switch electronic signals and electrical power. The Universal Automatic Computer, so the UNIVAC, was introduced in 1951. It's particularly famous for predicting the outcome of the US presidential election. The numbers were so skewed that they thought the computer was in error and the prediction was consequently not read. It was later announced after the election results turned out to be in line with the computer's prediction. This is the era when stored programs became a thing. A lot of programming languages sprouted around this time. It also ran an operating system which was new at the time. In Module 2, we will learn why this is important. A widely used programming language called Common Business Oriented Language, or COBOL, was used to develop a lot of business systems, while other competing systems were written in assembly language. New terms such as bits and bytes started springing up and became commonplace in describing data. Did you know that your phone carries more processing power than the computer that sent the first astronauts to the moon? Amazing, isn't it? Which brings us to the third, fourth, and fifth generation. Modern-day computers are mind-bogglingly more powerful than the massive machines from the 60s. New features such as parallel computing, multitasking, graphics, and sound came into the picture. This made computers a whole lot more capable and a whole lot more useful to the average person. Programming became a whole lot easier too. Who knew we could go from interconnecting a load of wires to taking a course at Shaw Academy online to learn programming? The applications of computers took off in various directions. The introduction of integrated circuits, ICs, meant computers could be a lot smaller and do much more than they ever could previously do. They were more reliable than all previous generations because ICs are more robust and much less likely to break down. High-level languages are much more common nowadays. They look and sound like English. This makes it a lot easier to take up coding and develop complex programs in a short space of time. The future is taking a really exciting route, notably in artificial intelligence, Internet of Things, machine learning, and quantum computing. We are going to break down these terms a little now. Artificial intelligence involves programming a computer with the ability to mimic human intelligence. Alan Turing, commonly referred to as the father of computer science, devised a test to determine a computer's ability to exhibit intelligent behavior that is equivalent to or indistinguishable from that of a human. In this test, a human evaluator would communicate with subjects A and B, where one is a machine and one is a human being via a text-only channel. The human evaluator would then evaluate the responses and tell apart the machine from the human, based on the machine's ability to give answers that closely resemble human answers. Quite interestingly, for the first time in history, in 2014, A computer program called Eugene Gustman, which simulates a 13-year-old Ukrainian boy, is said to have passed the Turing test at an event organized by the University of Reading. The Turing test is successfully passed if a computer is mistaken for a human more than 30% of the time during a series of 5-minute keyboard conversations. Recently, there has been major advancements in self-driving cars and other autonomous vehicles. Advances in communications have made computers able to gather loads of information from the environment, process it, and produce output at blisteringly fast speeds. The Internet of Things has made it possible to build smart gadgets and smart wearables that interact with your body and with the environment and make your life a whole lot easier with minimal effort. Some examples of Internet of Things devices are smart speakers like Alexa and Google Home, smart watches like Apple Watch and Garmin, and Internet-connected monitors and biometrics. Wikipedia's definition of quantum computing is an area of computing focused on developing computer technology based on the principles of quantum theory. The quantum theory attempts to explain the behavior of energy and metrics on the atomic and subatomic levels. Pretty advanced stuff. The world of quantum computing is promising to dwarf current computing capacity many times over. Recent days have seen research on quantum computers which promise to speed up computing by adding a new twist to the ordinary 2-bit system that runs every single computer in the world today. To date, it still exists mostly in theory, although working demonstrations have been produced. Coming up in our next lesson, we will learn how a computer processes information and the procedures it goes through to convert that information into something a human can understand. We will also start to dive into different operating systems, their structure and characteristics. By the end of this lesson, you will know exactly where programming falls into all of this. Moving on to another topic. We are going to look at the applications of computing. Computers are now at the center of business operations. Stock markets, payroll calculations, budgeting, sales analysis, financial analysis, and business performance analysis, etc., are all reliant on computing. This is just the tip of the iceberg. Can you see just how many opportunities there are if you get into the world of computer science? All banks nowadays are completely dependent on computing for their operations. ATM machines are completely automated, with some even having the ability to take deposits. Most banking operations can now be done in real time, thanks to the vast network of computers that support transactions. Global payment partners enable people to transact without borders, having millions of lines of code as their backbone. Business communications have almost entirely gone digital, with things such as phones also migrating into the digital space. The reliance on computing offers a lot of opportunities in business circles. Systems development, data analysis, mobile front-end and back-end development are some great professions that are in the spotlight of late. Have a look at the job specs out there for these positions and see if anything pops out at you. Businesses sometimes require bespoke software and require the services of a computer scientist to analyze their business model and operations and come up with a tailored solution. Many companies now maintain databases of their work and use collaborative solutions that allow a number of people to work on a single document at the same time. Manufacturing is now much faster with the use of perfectly choreographed robots that are precisely controlled by computers. Looking at consumer electronics, this has been a huge area of development in recent years. It's amazing that now we live in an age where even cars get regular software updates. The most notable industry in this regard is the Internet of Things, which I mentioned briefly earlier. This is basically the interconnection of practically everything while giving it some form of intelligence. You may have seen the word smart pop up a lot in the recent years. Now, this usually means the device in question has some sort of data gathering and/or processing ability. As we saw at the beginning of the lesson, or as you might have picked up along the way, data in computing is everything. Without data, computers would not be able to do the amazing things that they're now capable of. Computer scientists are presented with situations that require innovation and come up with solutions. Computer electronics is one of the most explosive industries in terms of growth, with Apple Inc. being a notable example, being the first trillion-dollar company in the world. Other companies like YouTube, Facebook, and TikTok have seen rapid growth in recent years because of the growth and increased available consumer computing devices. Smartphones are the center of attention here. They evolved from being simple bricks that we use to call and text each other to being the single most used type of gadget for content consumption in the world. Programmers and businesses are constantly trying to find ways in which to enhance the user experience. Some phones now ship with artificial intelligence chips built in to further enhance the computing experience. Within a short space of time, the mobile phone has replaced a lot of other things that we use to carry around in our pockets. With recent advances in processing and interconnectivity, electronic items such as televisions, mobile phones, soundbars, and even headphones are now able to respond to natural language commands. A lot of electronic devices are now available as assistive technologies for differently abled individuals. Recent electronic shows had robotic arms and other contraptions that can be controlled by thoughts alone. There is a lot of research going on around tech that lives inside the body. Yes, inside the body. Perhaps in future, people will be able to communicate without having to carry a mobile phone. Smarter consumer electronics have made life a whole lot easier and safer for people. Imagine having a cooker that knows when you have forgotten to turn it off, then safely shuts itself down. Pretty cool, right? As computer science advances, we are going to see smarter and smarter devices that will drastically reduce injuries and deaths associated with electrical and mechanical equipment. Scientific research owes its sky-high achievements to computing. With computing devices, scientists can accurately model difficult and complex scenarios and analyze them in fine detail. From as far back as the 1960s, computers have been used in research in conjunction with mathematical models to produce simulations, models, and projections. Weather forecasts have now become more accurate with the use of carefully designed modeling tools and data analysis. Humanity has been able to safely leave Earth and return by simulating never-seen-before environments and building suitable equipment. Computers are also used in the research and fabrication of new, faster, and better computers. In this lesson, we looked at the roots of computer science and why it is such a great field to take up. We looked at the many exciting fields that computer science is made up of and the many more exciting fields that are coming up. In Lesson 2, we will start exploring the inner workings of a computer and see how it is able to do the amazing things it is capable of. In this course, we are going to take a ground-up approach in learning all about computer science. To start off, we will look at the very basic concepts that make up computer science, human communication, and the science behind language. We then jump into problem formulation and statement, one of the pillars of computer science. We jump into the basics of programming, all you need to know to get started with nearly any programming language. We then learn how to read and understand code, an invaluable skill that you will use for the rest of your life as a programmer. We finish off by learning how to build solutions to all the problems that we've been stating and analyzing it along the way. I have a challenge for you in this lesson. I would like you to have a look at a few articles on why computer science is such a buzz these days and will likely continue to be for a long while. Post any tips or interesting info you find on our Facebook page or tag us on Instagram with the hashtag Shaw Computer Science. There are summary notes available for purchase within your profile on our website and app. These are a fantastic resource, helping you to prepare for the assignments and answering any questions you have on the content. After each lesson, there is an optional quiz available to you in your profile. These are not compulsory, but they really help cement what you've learned in the lesson. Give them a go. If you have very specific questions about a lesson, you're welcome to direct them to your educator. Please email support@shawacademy.com and they will get back to you as quickly as they can. Remember, all the summary notes and slides are available in your toolkit and would really be worthwhile to keep as a resource at your fingertips beyond this course. But no sneak peeks. The lesson notes will only become available after you have attended your class or caught up with the lessons. These will also help you prepare for your first assignment. Congratulations, you have completed your first lesson. I hope you've enjoyed it. I will see you soon for lesson 2.